Hi everyone. So this is the problem statement that we've arrived upon by using the analysis data for the tall building that we designed on ETABS. And now we'll be designing a math foundation for it using this data only. Now we will calculate the subgrade modulus, which is the ratio of safe bearing capacity of the soil to allowable settlement, and the design strip width, which is 0.25 times the shorter dimension of the mat footing, which we'll here take as 4 meter. So now to create the model, we'll open Safe software. So we'll create a new model using design code, which is IS 456. We'll set the current units as metric and change the design preferences according to the IS code. Then we'll specify the number of grid lines and the grid spacing that we'll be using to create the mat footing, which is 19 grid lines 1 meter apart each in X and Y directions. And now we'll begin by defining the materials we'll be using. As we design the building in ETABS software using M40 grade concrete, so first we'll be defining that here. These values we're defining here are constant for a particular grade of concrete. And for reinforcement, we have used HYST 500 grade for the design, so we'll be defining it here now. We'll then move on to define the slab or the footing properties. The slab material that we've used is M40 grade concrete, and the type is mat footing. We're starting with a thickness of 500 millimeter. Now we'll define the column properties. As we have used two types of columns in the design, so we'll have to define two properties for the columns with varying cross sections. That is 500 into 500 mm for one, while 600 into 600 mm cross section for the other. Now we'll define the soil properties using the subgrade modulus that we calculated in the beginning. We'll then check the load patterns that have to be dead and live, and the load case type, which have to be set at linear static, as we are only performing linear static analysis now. We'll then set the load combinations according to IS 456, in which ultimate load combination will have the scale factor for dead load and live load as 1.5. And for the service load combination, the scale factor for dead load and live load will be 1. And here we're done with the two load combinations. And now we'll use the draw slabs or areas option to draw the footing area. And we'll have to ensure that the correct property is selected as we have defined. But to accommodate the corner columns in the footing area only, we have to expand it 2 meter along each side using the edit tools. Note that there are two types of column with properties as column 1 and column 2, so we have to place them accordingly on the grid, or we can say the mat footing. And then we'll create the design strips. We have to ensure that the design strip width is changed to 4 meter as we have calculated earlier. The design strips in horizontal and vertical directions are created in separate layers, that is layer A and B respectively. We'll then assign the soil properties to the footing and loads to the various columns. And according to the analysis and design results in ETABS software, as load is different for each column, so we have to assign it individually. And then we'll change the rebar material of the footing as well as the design strips to HYSD 500 that we defined earlier. Ensure that your selections are made correctly. Now we'll save the file and run analysis on it. And by default, we'll be able to see the displacements due to dead load. And now we're ready to perform the design check. And after that, we'll go to show punching shear design in the display menu. As we can see, for many of the columns, the punching shear ratio is greater than 1, which is needed to be less than 1. So what we'll do is increase the slab thickness and again perform the design check and then check for the punching shear ratio values. In case they are still greater than 1, we'll again perform the previous steps and ensure that they are less than 1. Otherwise, our design check has failed. And if all of them are less than 1, then a design has finally passed. We can also get its extruded view to see how a foundation design will look. And check for various results as follows. Here we can view the forces and moments for different load cases as well as combinations along both the layer A and layer B. We can also get the crack width for the top and bottom faces of the slab. And then finally perform detailing on it, upon which we'll be able to see the results such as rebar table, rebar schedule, bill of quantities, and the individual slab views, for example rebar plans, reinforcement profiles, etc. We may check for the other details as well. And with this, our project is complete. Thanks for your patience.